It's homework time. Yes, let's do it. All right, let's start by jotting our names down at the top of the paper. All right, my name. You write yours. Deal? Good. And then let's go ahead and take a moment, do things right. Write down today's date. I'll write today. You write the actual date. When you are. All right, so our instructions are, I love this, solve. Okay, so we are starting, and I like that they write out the words here so you can stop and realize that really all we're doing, like in A here, is we're doing 3 minus 2. That's it. 3 minus 2 is 1. That's all we're doing. Don't make it any more complicated than it needs to be. Just take a nice deep breath. 3 books minus 2 books is 1 book. Okay, so that's all we have to do with these basic subtraction examples where we have the same denominator, because we have 3 sixths minus 2 sixths will leave 1 sixth. And let's write out the words on each of these. And I like to say tenths, like a tent you sleep in when you're camping, for tenths. So 5 tenths minus 3 tenths leaves 2 tenths. Don't make it more complicated than it needs to be. But of course we're talking about actually tenths. But that's the point, is that they don't magically become something other than tenths just because we're adding or subtracting them, unless we do something differently. But in this case, these forts, call them forts, like an army fort, they can, they're forts. That's what they are. So 3 fourths minus 2 fourths leaves 1 fourth. It's born a fourth, it'll die a fourth, it is a fourth. All right, and 5 thirds minus 2 thirds. We're just doing 5 minus 2. Don't make it any more complicated than that. It's 3. I probably didn't have to tell you that, but we're talking about thirds. 3 what? 3 thirds. That's it. Well, that's not it, but that's it for that one. Let's go on. And here in number 2, it's the same thing, except that now instead of the words, we have the numbers. So when we look at 3 fifths minus 2 fifths, that should look somewhat familiar, it's still just 1 fifth. So we're just going to write the fraction 1 fifth. These are going to go really fast, and I'm not going to belabor it. We'll just kind of go through these. Because all we're doing here in B is 7 minus 3. Yeah, we're talking about ninths, so that's part of it, but hey, 7 minus 3 is 4. And we're talking about what? We're talking about ninths, Ed. All right, so 7 twelfths minus 3 twelfths. Well, they're twelfths. They're born twelfths, they live twelfths, they die twelfths. So 7 minus 3, just like in the last ones, it's still 4. And that's that. All right, now let's look at D. 6 sixths minus 4 sixths. It doesn't much matter that this is 6 sixths, which is equal to 1, except that this will be useful down the line. For example, if this were 1 whole, 1 minus 4 sixths, we would then do the interim step, at least mentally, of saying, oh, well, 1 is 6 sixths, subtracting 4 sixths. So there we go. 6 minus 4, of course, is 2, and we're talking about what, Ed? We're talking about 6. And then 5 thirds minus 2 thirds, that this is an improper fraction? Bah, who cares? It's fine. We just subtract 5 minus 2 is 3. And what are we talking about? We're talking about thirds. And now I realize in some of these I could do some simplifying and such and renaming, but my instructions here are solve. And so that's why we're just going to leave well enough alone there. And now 7 fourths, again, an improper fraction. 5 fourths, an improper fraction. We don't care. All we're doing is subtracting. 7 minus 5 is 2. And we're talking about what? That's right, Ed. We're talking about fourths. That's it. Let's go on. And all that's different here in number 3, it looks very different, but it's actually not, is that, as you see, let's look at this first example. We end up with a solution 9 sixths that's greater than or equal to 1, and that's what we're going to see in all these. And so instead of like in number 2 where we just solved, here we're going to do something with that solution, which is, right here, use a number bond to decompose that difference. Right here, here's the number bond. They said 9 sixths is 6 sixths, which is 1 whole, and 3 sixths. 6 and 3 are 9 sixths. And then record our final answer as a mixed number. As you see they've done here, that 6 sixths is equal to 1 whole, with the 3 sixths is 1 and 3 sixths. And we just looked at problem A. It's been completed for us. Let's just jump in and do one. So here we're talking about eighths, right, Ed? So 17 minus 6 is 11. And I can't make this any more complicated. It's just not complicated. So when I look at 11/8, it's an improper fraction. Its value is greater than 1. So I can pull out that 8/8 that I know is equal to 1 whole. And from the 11/8, how many eighths are remaining? Just subtract 11 minus 8. It's 3/8. So all I've done here, just to be clear, is I've said, hey, 11/8, I can think of that as 8/8 and 3/8, which is convenient because then I can take 8/8 and call it 1 whole, and 3/8 is still just 3/8. Got it? All right, let's do another one. So 9/5 minus 3/5, well, 9 minus 3, of course, is 6, and we're talking about fifths. I can decompose this. All right, what am I going to pull out? These are fifths, so I'm going to pull out the 1 whole as 5/5. And that leaves from the 6/5, what's remaining? 1 more fifth. And double check yourself. 5 and 1, okay, 6/5. Okay, good. Now the 5/5 right there, that's 1 whole, and I have 1/5. See, so I'm recording it as a mixed number, decomposing it with the number bond here. And this is actually, I tell you, a really useful way of thinking about it and doing the math. So 11/4 minus 6/4. Well, 11 minus 6 is, got it, 5. And we're talking about what, Ed? We're talking about fourths. All right, so I can decompose it here. Pull out that 1 whole. We're talking about fourths. So it's 4/4 is the 1 whole. And how many fourths remain then from the 5/4? 1/4. Okay, yeah, 4, 1, or 5. Okay, everything checks out. The 4/4 is 1 whole and 1/4. That's it. All right, so let's do these last two here. So 10/7 minus 2/7. Well, 10 minus 2 is 8. And what are we talking about? We're talking about sevenths. All right, and so let's decompose that. We're talking about sevenths, so when I pull out the 1 whole, it's 7/7. And that leaves how many sevenths remaining? 1. Okay, so the 7/7 is 1 whole. And then we have 1/7. See, so 8/7 equals 7/7 plus 1/7, which equals 1 1/7. Got that? Okay, good. All right, let's try this next one. 21 minus 9. Got it? What is it? 12. Okay. And then we're talking about what, Ed? We're talking about tenths. And because we're talking about tenths, we'll decompose 1 whole as 10/10, which leaves what remaining? 2/10. So the 10/10 is 1 whole, and we have 2/10 as well. And that's it for number 3. I mean, there are 7 examples tonight, but we are cruising. Let's cruise on, brother, sister. Well, brothers and sisters, we're going to pump up the volume with number 4. We're still instructed to solve it, yet now we're switching to addition. Same thing, just adding instead of subtracting. Write the sum in unit form. This is just like we did in number 1, but we're adding instead of subtracting. So 4 forts, or what do we want to call them, fits, like your little brother has a fit. 4 fits and 2 fits. Your brother had a total of 6 fits, which are actually fifths, of course. And we care not a whit that that's an improper fraction at this point. And 5/8 plus 2/8. Well, 5 and 2 are, you got it, 7. And we're talking about what, Ed? We're talking about eighths. And we write out the words here to keep in mind that we're not changing these denominators just by adding and subtracting in this way with the same denominator. And now here in 5, A and B, we're just doing the same exact thing, just in numerical form instead of unit form. So 3/11 plus 6/11. 3 and 6 make 9. And what are we talking about, Ed? We're talking about 11s. All right. And so again, still with tenths, you notice they're giving us very similar examples here. So and they do it for a reason, so you understand, like, hey, it really doesn't matter what the denominator is here. We're going to treat it the same way. 3 and 6 are still 9, but instead of 11ths, we're talking about tenths. That's what we're talking about, Ed. That's it. Let's go on. Cruising, I tell ya. Number 6, we're doing the same thing we did up above with subtraction, just now with addition. We're going to solve and use that number bond to decompose the sum and record the final answer as a mixed number. No problem. All right, so let's start off here. 3/4 and 3/4. Well, 3 and 3 are 6. And what are we talking about, Ed? We're talking about fourths. All right, and so let's decompose that. Since we're talking about fourths, how many fourths make one whole? Well, 4/4. Of course, we know that, don't we, Ed? And that leaves how many fourths? That's right, 2/4. So we can say then that 4/4 is one whole. And what do we have for a fraction? We have 2/4. So our mixed number is 1 and 2/4. Lovely. Let's go on. And some of you may see, just looking at that, we could put equals 1 and 1/2, although we're not simplifying. We're not asked to do that here. But anyway, 8 and 6 make 14. And what are we talking about? We're talking about twelfths. So that means when we pull out our one whole, since we're talking about twelfths, it's 12 twelfths. And on the 12th day of math, anyway, and how many twelfths remain then from the 14? Another 2, right? Because 12 and 2 are the 14. And so that 12 twelfths equals one whole, and we have 2 twelfths, so our mixed number is 1 and 2 twelfths. Let's go on to the next one. I'm going to kind of jog down a little bit here for my equal sign so that I have room, because it's sort of bleeding over here. 5/8 and 7/8. Well, what are 5 and 7? You know that one? Oh, yeah, you do. That's right, 12. All right. And we're talking about what? Eighths. So that means we decompose eighths to get the one whole. To pull that out, it'd be 8/8. And then how many eighths remain? You got it, 4. All right, because 8 and 4 are 12. All right, so that gives us, I can make a nice long equal sign. 8/8 is the one whole with a fraction of 4/8. Beauteous. Let's do D. We're just flowing on, rolling on the river here. All right, 8/10 and 5/10. 8 and 5 make, and again, I'm going to jog down a bit here with my equals, make 13. And we're talking about what, Ed? We're talking about tenths. So that means when I decompose the one whole out of that 13 tenths, it is in the form of 10 tenths. And from the 13, how many remain then? It's easy. Yep, you got it. Another 3. This is supposed to be a line, not a 1. Let me make sure that looks right. Okay, so then put my answer over here, make a nice long spaced out equal sign. 10 tenths is one whole, and I have the fraction still of 3/10. Yeah, just doing it. All right, let's groove on. So 3/5 and 6/5. Let's do it. 3 and 6 make 9, and we're talking about what, Ed? We're talking about fifths. So I can decompose that one whole out. Since I'm talking about fifths, it's 5/5. And that leaves how many fifths remaining from the 9/5? That's right, 4/5. So that means 9/5 is equal to, well, the 5/5 is one whole, and then I have the fraction 4/5. So 9/5 equals 1 and 4/5. Getting the hang of this, aren't you, Ed? All right, so now 4/3 and 2/3. Add 4 and 2 make 6, and we're talking about what? We're talking about thirds. Now, oh, look at this one. It's a little, oh, you notice something here. Yes, watch this. So we pull out that one whole as 3/3. And what does that leave? Oh, it leaves yet another 3/3. Boy, I wonder how we handle this. Well, this is one whole, and this is one whole, and what's 1 and 1 but 2? So our answer is the whole number 2. That's it. 6/3 is 2. We just have one left. Let's do it! Well, 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 you fell in the well. All right, so here is different. We have to solve and use a number line to model our answer. Notice that in A we're doing subtraction, and in B we are performing the operation we know and love called addition. So let me just go ahead and draw two number lines, and I'm going to use the space well here and make them nice and long. So there's 1, and this one I'm going to jog over a bit so I have room for my beautiful face in the corner. Sarcasm, Charlie Brown. Okay, and I know I need arrows at both ends of these number lines. It's just like geometric lines. They are lines that go on in both directions. And I'm going to make a starting and ending mark, but I'm not going to label them just yet, because I think I need to do the math first here so that I know how to label this bad boy. All right, so 11 ninths minus 5 ninths. Well, that's easy. We just did a bunch of this, right? So that gives us what? 11 minus 5 is 6, and we're talking about ninths. Okay, so this gives me a better sense of how I can label this line. So as far as a starting point goes, I don't have to start at 0. I very well could. Nothing wrong with that. I guess maybe I will. Okay, so we'll do 0. But I need to go at least up to 11 ninths because I'm subtracting. But why don't I go one more, just to give a little breathing room. Why don't we go up to 12 ninths, okay? And now I need between 1 and 11 here, right? Okay, so that's where this gets a little tricky. So I'm going to just draw. I'm just going to start drawing and labeling. But remember, I'm talking about ninths. So 1 ninth, 2 ninths. And if these aren't spaced well, then, you know, the answer, my friend, is blowing in the wind. You know, like, I'm going to do the best I can. 4 ninths, and I'm kind of trying, okay, these are probably a little too close, so I'm just going to start spacing a little bit more here. 5 ninths, but not too much, I don't overdo it. 6 ninths, so I need 7, 8, 9, 10, 11 here. Okay, yeah, I'm doing all right. And if yours doesn't come out perfect, that's not the goal. Like, the goal is, do you understand what you're doing? All right, so here's 9 ninths, and then I need 10 and 11 here. Good, I'm going to make it. All right, not so shabby. Not so shabby. All right, so I'm starting from 11 ninths, so I'm going to put a dot here, and now I'm going to hop on back just like you learned in kindergarten to subtract with the number line, right? Or was that first grade? Anyway, so I'm subtracting 5 ninths. So 1, 2, 3, 4, 5, and wow, it actually worked out. Can you believe it? Isn't it beautiful when things work out? And so I end up at 6 ninths, which is where I wanted and expected to be. Okay, so now again, let me do the math first on this one. So I'm adding 13 twelfths and 4 twelfths, and 13 plus 4, of course, is 17, and I'm talking about twelfths. And notice we're not going to decompose this or anything. We're just going to leave it as 17 twelfths. So when I look at my number line, you know, this is the largest number I have, 17 twelfths. So I at least have to go up to that. And again, I like having a little breathing room. So let's just make it 18 twelfths. Yeah. So look, it's going to be kind of muy ridiculoso to put all these lines here. So here's how I'm going to do this one. Here's how I'm going to approach it. This may or may not end up being 0. As long as I get down, like I really don't have to get down to 13. So I don't have to squeeze in all the way down to 0 here. So I can just like breathe, relax. Okay, so I'm going to go 17 twelfths. I'm going to go backwards down the line here. And wherever I am when I get to this mark, that's my starting point of my number line. You like that, huh? Huh? You like my nonchalant attitude? Here's my favorite quotation. You ready? Bah. I'll explain that someday. 15 twelfths, 14 twelfths. And see, I only really needed to get to 13. That's why I am not sweating something that requires no sweat. 12 twelfths. And here, I'm just going to go 11 twelfths is here. And then see, like this starting mark now is 10 twelfths. And that's okay. Because really, all I'm doing is going from 13 twelfths. And if your starting mark is something other than 10 twelfths, that's fine. It might be 9, or maybe you went all the way to 0, whatever. And now I'm going to go from 13 and add up 4 twelfths. So 1, that was horrible, 2, 3, 4, and I end up right where I'm supposed to be at 17 twelfths. So it worked. And look at what we did. Hot dog and hallelujah, pass the mustard. We finished another homework time, so I'll see you again next time. It is, once again, homework time.